Okay, some more simplifying of radicals. I have a 40 as a factor times m in here. This is not m squared, so it's not going to be able to come out from underneath the radical. So in this particular problem, all I need to do is factor the 40. You can either think of 40 as 4 times 10. That would be the fastest way to do this. And the square root of 4 is 2, so that's got to come out. And you got to write that as 2 times the square root of 10m, and you're all done. Or you can think of the number 40. Let's write it as its prime factor. So let's see, 2 goes into 40, and then there's 20 left, and 10 left. And looks like this is the prime factorization of the number 40. And so what you would see is that there's these two, that pair of 2's, and the square root of that would come out, and you'd be left with this 2 times 5 times n, or 10m under the radical. Let's take a look at just one that's a little bit larger in terms of the numerical coefficient. So I'm trying to really focus with some unusually large numbers here, 288y. So you know, if you look at that and just don't know where to start, 2 is the first prime number, so just go 288 divided by 2. And that gives you 144. Now 144 is in this list. The square root of 144 is 12. But let's say I didn't notice. Okay? And so I end up needing 2 times 2 times 2 times 2 times 2 times 3 times 3. Whoops. Getting a little tight there. Times y. Those factors multiply together to be 288. So I look and I say, oh, there's a pair. That comes out. And here's another pair that comes out of the radical. And here's another pair that comes out of the radical. And what's left underneath is a 2 and a y. You just have to be sure to multiply these numerical factors together to have a final answer. 2 times 2 is 4, times 3 is 12, times the square root of 2y. And you've simplified the square root of 288y. Let's now look at an algebraic expression again. Just one more glance at this. We've done this already. So I just need you to know that if I start putting trinomials, or sometimes even binomials, that you can factor, you need to be thinking about factoring this expression. This is a nice trinomial. This is an easy one to factor. It's got a 1 in front of the x squared term. So all I need to do is put the x's in the front, because x times x is that x squared. I need to look for two numbers that multiply together to be a positive 9 and add together to be a negative 6. That will be a negative 3 and a negative 3 because they multiply to be a positive 9 and they add to be that negative 6. So this expression, the radicand, is x minus 3, that quantity squared. And the square root of that is just x minus 3. Let's go ahead now and let's look at some monomials. Not trinomials, but monomials under the radical, or they are what's called the radicand, and let's simplify them. And so, oops, I meant for that to be a 10. I'm looking for the square root of x to the 10th. So what times itself gives you x to the 10 power times itself? What times x to what power times x to what power gives you x to the 10th? And those are 5s because you add them together when you multiply, when the bases are alike. So what I've discovered is that the square root of x to the 10th is x to the 5th because x to the 5th times x to the 5th is x to the 10th. And one of the things that you can do with a monomial expression like this, when you have a variable raised to a power, is the shortcut is to just go ahead and say, well, geez, I can just divide that exponent by 2 to get my answer. 16 divided by 2 is 8. X to the 8th times x to the 8th is x to the 16th because you add those exponents to get that 16. Shortcut, just divide by 2. So I have t to the 98th. So divide that by 2, and I believe that should be a 49. And you have simplified this expression. The bad news is sometimes that exponent is not divisible by 2. And so we have to come up with a plan for that. So let's take a look at something like that. So if I had an odd value for the radicand, the value under the radical, what I need to do, since I can simplify it by dividing the exponent by 2, I need to write this into two parts, two factors. One of the factors, exponents, has to be just below the 5. In other words, a 4. Because when I add those two up, I get 5, and that's what you do when you multiply. You add the exponents. And then this portion right here can be simplified. It can be pulled out from under the radical. It's equal to y squared. The square root of y to the 4th is equal to y squared, because y to the squared times y to the 2nd is y to the 4th. This y to the 1st has to stay under the radical. So it can be done. It's quite simple, really, when the exponent is odd. So if I have a 19 here, just go 1 less than 19 in terms of breaking this apart. This factor can be simplified. It can be pulled out from under the radical. 18 divided by 2 is 9, and this r to the 1st, or just r, has to stay under the radical. Let's just try a couple more, and we'll break this segment apart one more time. So if I have the square root of 104 p to the 17th power, and I want to reduce it, I'm just going to go ahead and use the prime factor approach. I'm going to do this down here because I need quite a bit of space. The prime factors of 104 are 2 times 2 times 2 times 13. And then p to the 17th would be thought of as p to the 16th and p to the 1st. So this pair could come out from under the radical. It's equal to 2. And this one could come out from underneath the radical. It's equal to p to the 8th power. So I have 2p to the 8th out from under the radical, and then 26p to the 1st stays under the radical because that cannot be simplified any further. Let's do maybe one more, a simpler one. I just have here the square root of 8p to the 5th power. So the other approach, a little bit quicker approach, is to think of 8 as 4 times 2. Think of p to the 5th as p to the 4th times p to the 1st. And the square root of 4 is 2. The square root of p to the 4th is p squared. They will come out, so I have 2p squared. And under the radical, I have to keep the 2p factors. They cannot be reduced any further. I think my last segment requires, a pause here at this point. You can take a break, and we'll talk about multiplying radicals and simplifying next.